Hello juniors, I hope you're doing fine today. Today we're gonna keep on moving with the new topic we started last week, which is about probabilities. And today we're gonna see Venn diagrams, which is something that I assume you have studied already last year. But we're gonna make a quick review about this and maybe get into some deeper concepts, but you'll see that this is very simple. Okay, so Venn diagrams, the objectives for today's class are number one, find the probability of an event A, then determine complementary events A and not A, interpret and apply Venn diagrams, define and apply combined events, define and apply mutually exclusive events. Okay, so let's start with some basic concepts about Venn diagrams just to review what this is about. Let's see it through this example. It says, there are 100 students in a year group. 38 of them do archery. This information can be shown on a Venn diagram. So here you have the universe, which is represented as a rectangle, and the particular event inside the universe, which is a student playing or doing archery, right? So it says, set A is students who do archery. In this case, the number of event A is 38. The rectangle represents 100 students, therefore the universe is 100, right? Then it says, a student is chosen at random. The probability that the student does archery is written as probability of A. And this is from last class. The probability of archery would be the number of students who do archery divided by the universe. That's 38 over 100, which if we simplify is 19 over 50. So this is what we've seen last class, how to determine the theoretical probability of an event. Then complementary event, also known as or denoted as not A. It says the area outside set A, but still in the sample space U, represents students that do not do archery. This is A prime or the complement of set A. So if we have 100 students, we know that 62, which is 100 minus 38, is the number of people who do not do archery, right? So how do we find the complementary event? It's the universe minus the particular event, right? From the Venn diagram, we see that the complement of set A is 100 minus 38, which is 62. So the probability that a student does not do archery is 62 over 100, which if we simplify gives us 31 over 50. So this is very important because this is the first property we're going to see today. The probability of the complement of A plus the probability of A should always give us 100%, right? Which is 1 if we write it as a decimal number, we would say, right? So this is why, right? Every student either does archery or doesn't do archery. For this particular universe, there is no other option. Okay, so this is where the formula for complementary event comes from. It says, as an event A either happens or it does not happen, right? So the probability of A plus the probability of not A should always be equal to 100%. So if we solve for the complement of A, we would say the probability of the complement of A is 1 minus the probability of A, right? In case you don't remember this, which is very simple, this is a formula. This is in the formula booklet, right? Let me show you that. If I go to formula booklet, here it says probability of A plus probability of not A equals 1. Remember, this is topic 4. When we talk about statistics and probability, you should look at topic 4 in the formula booklet. And here you have the first formula we've seen last class, and now we're doing this one, okay? So in case you don't remember, this formula here is in the formula booklet. Okay. Then we have intersection of events. It says, of the 100 students, 30 students play badminton. Of those, 16 do both archery and badminton. Okay? So it says, you can show this on a Venn diagram like this. We have the universe, we have people who do archery, we have people who do badminton, And here we have the intersection, which is people who would do both, right? So it says 38 students do archery, 16 students do badminton and archery. So 38 minus 16 is 22 who just do archery. So this is something that you need to pay attention to when working with Venn diagrams. If you're given this number 38, you don't directly put 38 here because there's a number of people who would do both archery and badminton. So the number that you would put here in this case is 22, which is this subtraction over here. So that's something you always need to pay attention to when working with Venn diagrams. Then it says 30 students do badminton, 16 students do badminton and archery. So there are 14 people who do just badminton, right? Which is this one. Remember, the addition of these two should always give the universe of badminton in this case, which is 30. And the addition of these two should give the universe of archery, which is 38. Okay? Then it says, the shaded region, this one over here, is the intersection of A and B. This region represents those students that do both archery and badminton. The region is written as A intersection B. So the symbol, the N symbol, is for and, right? It means that it means the intersection of both. When you read the clue word and, we're referring to this symbol. And when you read the clue word or, we're referring to this symbol, union, right? We're going to see that in a while. Then it says, there are 100 minus 22 minus 16 minus 14 equals 48 students that do not do archery or badminton. So we can find the people who do neither by subtracting the universe, which is 100, minus all of these elements. Okay, then it says the probability that a student chosen at random does both archery and badminton is written as probability of A and B. So we know that the number of people who do archery and badminton is 16, right? So the probability of A and B would be 16 over 100, which if we simplify is 4 over 25. Here it says, a number of A and B is a number in the intersection of the sets A and B. Okay. Then it says, if a student is chosen at random, then the probability that a student does not do badminton but do archery is written as probability of archery and not badminton, right? So if you look at the Venn diagram, we are referring to this shaded region over here, which is people who actually do archery but are not doing badminton, right? That's why we only focus on this region. So the probability would be this number divided by the total, which is 100, right? So 22 over 100 is the probability of people doing archery but not badminton, which if we simplify is 11 over 50. Here it says 22 students out of 100 do archery but not badminton. Okay. Finally, it says not A and not B represents the students who do not do badminton or archery. That is, all the people that are outside of the circles, right? So not archery and not badminton. Another way to interpret this value n is think about what these elements have in common, right? So if we look at not A would be everything that is outside A, right? And not B, let me do this with a different color, and blue. Not B would be all the people who are outside B, right? So you see that what they have in common is everything except all the interior part, right? All this part over here. So that means that we're only left with the green region, which is shaded over there. Right, so let me erase this. So if we want to find the probability of people who do not do badminton and who do not do archery and do not do badminton, this would be equal to what is outside of the circles, 48 over 100, right? And if we simplify this, let's try doing this without a calculator. So if we simplify this, we could divide this, for example, by 2. This would be 24. This would be 50. Then we can divide again this by 2. This would be 12. And this is 25. And I think I cannot simplify that anymore. No. So the probability would be 12 over 25. Okay? So that's it for intersection of events. Then we're gonna see union of events. So remember intersection, let me write that here. Intersection is the N, right? And union, what we're gonna see now, is the U. Okay, so it says union of events. The shaded region is the union of A and B. So when we talk about union, we're talking about all of this region. The region represents those students that do either archery or badminton or both. The region is written as A union B. The probability that a student chosen at random does either archery or badminton is written as probability of A union B. For this diagram, the number of people who do both or who do archery or badminton is this plus this plus this, right? 22 plus 16 plus 14, which is 52. Hence, the probability of A union B is equal to 52 over 100, which if we simplify is 13 over 25. Here it says, notice that OR in mathematics includes the possibility of both. We call it the inclusive OR. And then it says this is from the definition of probability. Okay, this. Okay. Then it says A union not B represents all those students that either do archery or do not do badminton. So if you look at this diagram over here, we're referring to the shaded region, right? A union not B. A would be all of the circle for A, and not B is everything that is outside of B, right? So if we shade all of the regions that we just described, we're gonna get all of this blue region that is already shaded here, including the intersection, because that is being included when I say probability of A, right? Which is this whole circle over here. Okay, so the number of A union not B would be everything except 14. So 22 plus 16 plus 48, which gives us 86. So the probability of A union not B would be equal to 86 over 100, which if we simplify is 43 over 50. Okay, here I wrote something which is clue for you to remember. The clue word when we talk about N, which is intersection, is and, okay? When we say archery and badminton, we're referring to the intersection, right? And when we say, and when you see a symbol U, that means or, and that means that we could either have someone who only does archery or who only does badminton or who does all three, right? So when we're referring to the word or, we're referring to all the different possibilities in the universe, right? Only badminton, only archery, or both. Okay, so remember those two clue words in order to analyze the probabilities. Okay, so let's see this example to ground concepts. It says in a group of 50 people, 29 like eating fish, 38 like eating chips, and 9 people like neither fish nor chips. How many like both fish and chips? Okay, so let's do our Venn diagram for this situation. I'm gonna make the universe first. The universe should look something like this. I'm gonna make one circle for fish and another for chips, right? We're having two circles in this case. So first circle over here, second circle over here. I'm assuming that they have an intersection because I see that 29 plus 38 is a number which is greater than 50, right? So there should be some people who like both eating fish and chips. Okay, so universe The total universe in this case is 50. So then I'm going to write fish would be one circle. So this is fish. And chips is the other circle here, chips. So the only thing I know for sure is that there are 9 people who like neither, right? So I'm going to write 9 outside of the universe. Outside of the circles, not of the universe. And, well, to solve this, I need to write a number or write a value for the intersection, right? Because I know that, I still do not know how many like both. But what I know is that there are 29 people who like fish in total. That means that outside of the intersection, I should have 29 minus x, right? I still do not know how many like both. And for chips, I know that there are 38 people in total who like chips. So I'm going to write here 38 minus x. Once I know this number, I will be able to calculate the exact values, right? So in order to respond to this question, how many like both fish and chips? If I know there are 50 people in total in the universe, I know that this element plus this element plus this element plus this element should give us 50, right? So I'm going to write that equation here. I'm going to say that 29 minus x plus 38 minus x plus 9 should give us the total, which is 50. So you see that here, by doing this, I only get one variable, which is x, and I can solve for x. You see that here, we can simplify this x with this x, and let's see if we can do this without a calculator. We would get 29 plus 38, that is 57. 57 plus 9 is 66, right? So we're going to have here 66 minus x equals 50, right? Let me double check this. Sorry, I think this is wrong. This is 29 plus 38, it's 30 plus 67. 67 plus 9 should actually be 76, right? 76 plus 38. Yes, 76. Okay, so 76 minus x equals 50. So then we can solve for x. We could leave the x alone. 76 minus 50, that would be 26. So now we know how many people like both fish and chips, right? We know that the value of x is 26. So to answer this first question, how many people like both fish and chips, we would say that 26 people. So people who like both. Fish and chips. Okay, so now that we know that, let me write this with a different color. I know that this is 26. So this number over here should be 29 minus 26, which would be 3. There are only 3 people who like only fish. And there are 38 minus 26, that's 12. 12 people who only like chips, right? Okay, so now that I have all of the elements of the Venn diagram, this problem becomes much easier. Let's go to, okay, so we already did part 1. Draw the Venn diagram to show this information. Now let's go to number 2. It says, use your Venn diagram to find the probability that a person chosen at random from the group likes A, chips. So the probability of a person liking chips, and you see that it only says chips, right? So I need to consider the complete circle for chips. If it said chips only, then we're going to be talking about this number, right? But as it does not say the word only, we need to consider the whole universe for chips. So that is, we know that 38 people like chips, right? So 38 over 50. And whenever we can simplify this, we need to simplify this. So if we simplify divided by 2, it should be 25 divided by 2, it should be 19. 19 is a prime number, so I cannot simplify this anymore. So this would be equal to 19 over 25. This is the probability of picking someone who likes chips. Then part B says the probability of both fish and chips. So probability of people who like both fish and chips. When we say both, we're referring to the intersection, right? So we know that there are 26 people who like both. So the probability, if we write this mathematically, this would be fish and chips. And this would be equal to 26 over 25. That's a little, over 50. That's a little bit above 50%. If we simplify this, this would be 25 here divided by 2 is 13. And I cannot simplify this anymore. So this is 13 over 25. Okay, then for part C, it says fish but not chips. If we say fish but not chips, we're referring to fish, let's see, fish but not chips. We're referring to this region over here, right? It's people who like fish but do not like chips. So we're excluding the intersection, and we're also obviously excluding chips, right? So if we write that in 2 words, this is probability of people who like fish, but it is also a word for intersection, right? Fish but do not like chips, so not chips. We know from the Venn diagram that that should be equal to 3 over the universe, which is 50. 3 over 50. Okay? If you want, you can always draw the Venn diagram first to represent the information. For example, if I do, let me do this. If I do the Venn diagram for part C, I'm gonna make it this smaller. If I do the Venn diagram for part C, then we would say that, I'm gonna erase this already, I already know the values. So if I wanna find a probability of F intersection not C, we should know that we're referring to this region over here. Only this region over here, which is equal to 3 over 50, right? 3 divided by 50. We cannot simplify that, so that stays like that. Finally, we have a part 3. Let me see if I can do it here. If I separate this, I hope I have enough space. Part 3. It says, describe in words, part A, describe in words those people in the set F prime union C. How do we describe this in words? We're going to say it's the number of people who do not like fish or like chips, right? So, the number of people, who do not like fish, or remember the clue word when we have union is or. Union is or. So or, that R is a little bit messy. Or like chips in this case. Okay, and part B says find the number of people who do not like fish or like chips, right? If we do, once again, the Venn diagram, let me copy this. If I copy this, if we do the Venn diagram for this, let's see if I can make it fit here. If I do the Venn diagram, then what is a shaded region for this situation over here? If we write this mathematically, we would obviously write this, what we have here, right? So that's F prime union C. Where do we find F prime union C in the Venn diagram? So it's not F, outside of F. Let me sketch that. I'm gonna do it with a highlighter. I think it's easier. If I shade not F, that's everything that is outside of F. So it should be something like this. Outside of F, union C. What is C? We know that C is all of this circle over here. So we're painting everything except this 3 over here, right? So the number, that is what we're asked to find, the number of people who do not like fish or like chips. So the number of F prime, this is just to avoid confusion, this is a small n, number of people who do not like fish or like chips would be equal to 26 plus 12 plus 9, which is equal to 47. Okay, and that's it. We're not asked to find the probability. If we were asked to find the probability, then it's this divided by 50, right? But since we're not asked to find the probability, just the number of people, then the answer is 47. Okay, and let me check this. 26 plus 12. 26 plus 12 plus 9. Yes, that's 47. Okay. So that will be it for today's class, people. I don't want to make this too long. We're going to see the second part of this for the next class. So I hope this was clear now for you. I think this is easy. It's still a review from last year. So I assume this would be clear now for you. If not, please let me know. We can cover these doubts in the live sessions. See you, juniors.